Greetings and welcome to this fourth video on the ConfirmaXL Design System. Hopefully, if you're watching this fourth video, it means that you've gone ahead and you've installed ConfirmaXL and as well as all the point tools that it needs to operate. And you're pretty close to ready to starting in the design of IC related circuits yourself, which would be terrific news. But In any case, I think we have to recognize that there is a fairly decent learning curve for Conforma XL, as there is for any IC design platform. So I thought I would do a few videos maybe of giving sort of an overview and a tour of Conforma XL through some simulation examples. And hopefully that will help people get up to speed and started, and also in becoming familiar with some of the features of ConfirmaXL and how you move across the different platforms. So with that said, we'll go ahead and get started here. Now, I made this list of topics that I thought I'd like to cover, but I think it's too much to do in one video. So I'll probably touch on some of this stuff and then come back to some of these topics in other videos. So we'll start with some simulations. Probably simulations using example test benches that were provided with the installation, and most of those revolve around simulating or characterizing the PDK, the process design kit that was also part of the initial Confirma XL install. So with that said, let me pop down here. So we'll open up some schematics, some schematic test benches, and we'll do some simulations across the different simulators, and we'll open up the schematics in a variety of different ways so you can see what's going on there. So all right, let me drop this down here. So I'm doing a fresh start of Confirma XL for my desktop using the shortcut. So let me double click on that, and ConfirmaXL starts up. When it starts up for the first time, or from the last time you used it, it always starts with whatever the cell was that you used when you last shut it down. So if at the end of the day you quit ConfirmaXL, it saves that test bench. Usually the top level cell is a test bench, and then when you start up the next day, it's ready to go. So if you're working on the same cell as yesterday, you can just open up that schematic right from the Confirma cockpit by hitting this button here, Open Schematic. But we're going to do things a little bit differently. We're going to open up the library manager. So open up the Confirma library manager. So this is still a work in progress, and you can see some of the colors are a bit lurid here. We'll probably change things moving forward, but it still it functions pretty well as a library manager. And so you have basically two different types of schematics that you're dealing with in your IC design. You have the schematics that have the transistors and the foundry devices, and it represents the cells that are actually going onto your chip. And then you have test bench schematics, where you're exercising those cells to make sure that they work properly, and they meet your specification, and so on. So for simulation purposes, you're usually simulating from the top level test bench. So if you look here, when the library manager opens up, you have different areas. You have this source area, you have a destination area, and that's so that you can do copy or erase operations from different working areas. And um, let's see. So we're going to have to move pretty quick here because I can see we're low on power on my laptop. I didn't expect that. So we have test bench selected. So in our guest working folder, um, which happens to be what we're set to on the Confirma interface. So if you look at my working here, you can see that my working folder is set up to the same path that's the file manager, the library manager opened up initially, which is a good thing because you always need to do your simulation. Your test bench should be in your working folder. So you do your simulation, your test bench from your working folder. Now, other cells can be from any area that's accessible to your design. So it could, if you have cells on your test bench, they can come from colleagues' working areas or other libraries, things like that. But the test bench should always be in the working in your working folder. So that's important. So if you click on one of the cells that's listed as a schematic, a test bench schematic, in your listing here, your library listing, that anytime you pop on one of those, it'll move into this source name area. So if you select IV curve and you then hit view source schematic, that should open that schematic in Kicad, and it does. So we could simulate that one if we wanted to. But I'm going to simulate this ring oscillator one. I think that's a little more interesting. So I've clicked on that. We're going to view the source schematic. Um, so it should open in just a second here, and it does. So it turns out that that was the one I was working on yesterday. So that was already preloaded, but in case it wasn't, you would do this pass to confirma operation, and you just do gen here. And what that does is it passes over to confirma what the cell name is, the test bench name is. So that would, if it was different, that new schematic would show up here. It happens to be the same, so there's no change here. But now Confirma knows that you want to simulate this test bench. So when you do that and you hit hierarchy here, it lists the hierarchical symbols. So symbols that have underlying schematics that happen to be on this page. So the only ones that do are these inverters. And let's see. So if you wanted to see one of those inverters, what was on there, you would do view schematic, and it should open up the underlying schematic for that cell. So, okay, so let me close that, and let's take a look at what's on the schematic page before we do a simulation. So there's two ring oscillators on here. One is a ring oscillator built with inverters shown as individual transistors with transistor symbols rather. So it's five stages of inverters, and then the output feeds back to the input to close the loop, and so you have a digital inverter. And then down here is another inverter, but it's built with these cells, and so with these inverter cells. So the difference is, it turns out that this one is built with minimum length inverters, whereas this one has longer channel length inverters. And so we're going to expect that this inverter simulate at a uh, will oscillate rather at a lower frequency than this inverter. They're both five-stage inverters. Now we're going to plot the waveforms, and um, we need to know what nodes we're going to plot. So the connections they do have labels on them. So this one's specified as ring 2. That's the name of that node. And then this one is just simply called ring. So if we plot ring, we know we're doing this inverter, the slow one. And then ring 2, that'll be the fast inverter. This is the power supply. The power supply has a label. That node is labeled, and that label is shared. So there's a connection via label between these 2 points. So this guy is also powering this cell as well. These are current pulses, and they're short current pulses. It's just to kickstart the oscillator to get it going faster. Sometimes they'll start up by themselves in the SPICE simulator just due to simulator noise, but it can be helpful to get them to start up quick if you put these current pulses on there. So that's a quick overview of what's on that test bench. So we'll go ahead and take a look here. So you can see there's this multi-tab interface. There's various tabs that you can look at. Two you're going to use most of the time are the Include tab and the SPICE Circuit Netlist tab. So that one has the netlist that came from the schematics. So if you do fast netlist, you saw that flash. So just re-netlisted from the KiCad schematic. So this is the SPICE representation that the simulator needs from that schematic. So it's nice to be able to see that too. If you're building your circuit or your symbols for the first time, it's nice to have that presentation to you so you can make sure that things net listed the way you wanted. When you create symbols, it's always possible to make a mistake. So it's nice to be able to check that. Then on the include file, so really what goes here, it's optional. It could be SPICE commands, it could be SPICE simulation commands like .trans, .ac, dot whatever. It could have dot save if you want to save all the voltages or only some voltages and currents. You can put all those commands if you wish in the include file. Alternatively, you can use forms. So, oops, I didn't mean to do that. I hit the wrong one. So let me go to choose analysis, and that gives you this SPICE analysis page, and that's multi-tab also. So you can set up your SPICE simulations using those various tabs. Sometimes I use the forms, and then you can save and recall your form settings. Sometimes I do that. Sometimes when it's just simple and I remember the commands, I don't always do, then I'll just write them on the include page. And so one thing to know is that different simulators sometimes have different syntax for the commands, whereas fortunately the compatibility is pretty good on the SPICE netlist side. So as long as if your simulator is HSpice compatible, the net listing side should line up and it should simulate without errors. But sometimes there's different syntax required for the commands. So that's important, something to be aware of. And we'll see that in just a minute, actually. So we've got our schematic page. We saw how to open up a schematic and do the handoff from the Confirma library manager. So that was something I don't think I've shown before. And so now we're going to do some simulations. So again, just like we had multi-tab interface up here on the top, we also have a few different tabs on the side. And so we default to the Kicad sheet navigator, and that's what allows us to do this hierarchical listing and then also up down the hierarchy. So that's how you transverse the hierarchy, and I think we saw that's how we got into some layouts. We're not doing layouts today, but in previous videos, I think I showed some stuff there. So then on the SPICE simulator, so you select this tab, and then that presents the user with the options you have for selecting different SPICE simulators. So when you select a different simulator, nothing changes on the SPICE netlist side. That all remains the same, but the include file can change, and it usually does. So if topspice, that has one set of command syntax, it's a pretty common one though. So this is the include file for topspice, but I'm going to click on Xyce, and you can see that it's a little bit different. So one thing that's important to know for Xyce, if you're simulating for Xyce and you want to still use the Topview viewer, you need to have this print. You can look in the Xyce manual for the exact syntax, but we're doing transient simulation. So you say dot print and then the simulation type, which happens to be transient, and then you do format, and you want to make sure you save the data in a raw format. If you save it in a raw format, then TopView is able to open the data, and then you can plot it. So you can use the same TopView plotter, and you can view data from a lot of different simulators. It's very flexible, and that's why I like this Topview tool. And you can use the demo version, which is free. So I don't know how other people are viewing data from NGspice and Xyce. I think they're using all kinds of different things. I don't know. It's nice to be able to use just one single tool. Is already enough to learn about an IC design. It's nice. It's nice to be able to use one single tool. And honestly, the same thing with KiCad. So being able to use different simulators from the same uh, KiCad schematics, that's a powerful thing. So if you want to use topspice or Qspice or LTspice. The only way I'm aware of really to do those kinds of things outside the Confirma platform is you have to come up to speed on all those different schematic capture programs, and that's a pretty big effort. And honestly, I just think it's a waste of time. So hopefully this will people will find this easier to use, and it'll give them the flexibility of using variety of different simulators. Different simulators have different capabilities, so having that flexibility is really, really super. And there's some things I'll be showing in the future that will highlight what I'm talking about there. So at any rate, let's do some simulations now. So we're selected the topspice. I'm going to hit simulation. Okay, so topspice ran. We'll view the plot. Um, see, ring and ring 2 is what we're really after. I'm going to put this on different plots, I think, so they'll be easier to see. Okay, this one's on plot 2, add. Okay, so we have the slow oscillator up here on the top, so that has the long channel devices and then short channel devices on the bottom. You can see the frequency of oscillation is much higher. So they're both 5-stage oscillators. So let's leave that there on Topspice, and we're going to simulate with Xyce next. So I switched over to Xyce, going to hit simulate. So Xyce has just ran there, view plot, and I'm going to move down here, ring to, let me see if I can do that again. Put them on different add. Once you get used to this top view, I think you will like it. I mean, it doesn't have everything that you'd like to have. One thing that it has that's important, if you like RF design, it has Smith chart. And Smith chart is, you can work around, you can do things without it, but it's nice to have a Smith chart. And it turns out that, and maybe I'll show this in the future because we're working on this, you can have things like now you don't get this with top view automatically, but you can program it. There's a way to do the mathematics so that you can do things like stability circles, gain circles, noise figure circles. So those are options that we're working on, and we hope to offer in future version of ConfirmaXL. So so far, so there's Xyce, there's Topspice. You can see they look the same, and they're simulating from the same model set. So they're simulating from ESMG, P180 nanometer, the simulation PDK we provided as part of ConfirmaXL. So, okay, so those are two of the simulators. Let me go to this third, NGspice, and let me hit the sim button there for NGspice because we don't want to slate anyone. Okay, oh, let me do that again. Here we go. Add, and to add. Okay, there we go. So that looks the same also. So all these things look the same. So let's see. So we just, what did we do? So we opened up the schematic using uh, the Confirma Excel library manager. Um, so we opened up the schematic in Kicad, and then we passed the schematic information from Kicad to Confirma Excel using the pass to Confirma command. From there, we net listed. We did net list the schematic using the fast net listing. Um, we saw what the schematic net list looked like. We talked briefly about the include file, how you can have different include files depending on which simulator that you're using, and that enables you to uh, do multiple simulations very quickly by simply switching the button here. All those simulations work from the same netlist. Um, no changes there. So I think that's a pretty powerful thing. A lot of flexibility. Let's see what else. So I think maybe I should call it quits for now. So we've been about 20 minutes. I'm trying to not to go too fast. We did talk about so this is our working folder. So our working folder is the default folder that Confirma, when you installed it, should be set up for this. I'll talk about switching that in a different video, I think. And then um, just like you can open up the working folder from a button, uh, same thing, the simulation data that happens to go to a particular place, that's something that you set up as well. So our simulation data is going to this path here. And if you wanted to look at the status of your simulation, all the files, you can do so. You can open up that folder. And one of the reasons they're separated like this is after a while, your collection of data there can get quite large, and it can start to fill up your drive, wherever that may be. And so once in a while, you'd like to get in there and clear that out. Um, let's see. So that's that. And let's see. So we talked about the different tabs here. Um, how you select across the simulators. And by the way, when you do this, so you select Topspice, there's a little there's some notification over here. So if you're looking at the interface, you can see what simulator you're set to, even if you're not looking at this specifically. So as you select Zeiss, that switches here. The same thing happens on the layout side, or we're not doing any of that layout stuff today, but you look up here, you can say, okay, I'm using Zeiss and I'm using it with K layout. So it's nice to be able to see that at a glance. And then let's see. I think in one other video I talked about simulating schematic view versus LPE view. Uh, Now here's something to know. Let's see. Let me go back and set that to topspice, and I'm going to go here. And turns out, model files. I'm just going to touch on this. I'm not going to say too much about it. But if you open up this project model folder here, so our project, every project has a models folder. So our project is my chip designs, PSMG, P180. So that up to here is the project. So this section here, that's denotes the project. And so this models file, every project has a models file, uh, a models folder rather. Sorry about that. So that's where the models are kept. So um, now, to keep things easier to understand, we have these MDL files. So the process MDL that contains all the pointers to the HSpice libraries needed for that process. So the HSpice model files themselves, they're a collection of other files. And generally, the approach that we take is each type of transistor, for instance, for that process has model files contained in uh, its own file. And so we have process MDL that contains the process related pointers. And then we have behavioral MDL. And sometimes we have to have different behavioral model files tuned to each simulator. So we're fortunate in this case on the PSMG, actually it's by intent, P180, those HSpice model files are set up in such a way that they work on all these simulators I just chose. Otherwise, you would have to have a different set of um, foundry models for tuned to each of those different uh, um, simulators. So but that's actually a good thing in ConfirmaXL because you're able to have that. You can have process models tuned to a simulator, and Confirma will ensure it'll keep track. So whatever simulator you choose, it will make sure that the process models for that simulator get packaged up with your circuit when it's sent off to the simulator. And so that's kind of an important feature, and it's one of the mechanisms we use to allow Confirma to support all these different simulators from the same schematics and the same schematic derived SPICE netlist. So that is the models folder. If you want to actually see what's in the process MDL file, well, you can do so. So you have this button here, Open Process MDL file, and it shows you what's in that process MDL file. So here is the listing of various HSpice um, model files that are associated with the PSMG 180 nanometer process. So just as I was saying, each type of transistor has its own model file. So CV, that's the core voltage, NMOS, and PMOS, and that's generally the minimum channel type devices. You can have interface transistors as we do in this kit. So HV, that would be a higher voltage MOS. And so each of these files um, has BSIM3 or BSIM4 models specifically for those devices. So, and the same thing with resistors and MEMS and MOS varactors, things like that. So instead of having all those models in a single file, which is very difficult to navigate and troubleshoot, we've split them up, and it makes it much easier to manage the process files. And if you're not familiar with how HSpice models uh, are set up, and that can be quite a chore to navigate all that stuff simultaneously. So by breaking it up, it makes it much easier to understand and to manage, and also to troubleshoot. So if you're trying to move a process from one simulator to another simulator, and then all of a sudden the design won't run, the models won't simulate on the new simulator. It's much easier to navigate and troubleshoot where the problem is if you have it split up this way. So is what we've done here, and I'll talk more about this. I'll talk specifically about the PSMG P180 nanometer process, and also our efforts in moving Global Foundries 180 MCU process and the IHP process and the Sky process, moving all those open source processes to the ConfirmaXL um, system. So that'll be coming up too. So I'm going to end it there. Hopefully this has been helpful. If you do have ConfirmaXL up and running on your system, we'd sure would like to know. So if you can make drop in the comments, let us know. Oh, I've got it running. Also, it'd be interesting to know too, like what part of the world you're from. So let us know where you're from. You know, don't need a lot of detail. If you're working from a university, let us know what university you're at. We'd love to hear that. So hopefully this will be helpful, and we'll try and get some more videos going too to help you get started up and running. So thanks for sitting in. We hope you like the software. All right. Bye bye.